Hi everyone. So moving on to the next question, which is permutations or CSES problem set. So permutation. So a permutation of integers 1 to n is beautiful if there are no adjacent elements whose difference is 1. Given n, construct a beautiful permutation such if such a permutation exists. So basically we need to create a permutation in which no two elements have basically a difference of like no two adjacent elements should have a difference of 1. That is, neither of the elements should be like in between of like 1, 2 or something. So let's try to understand how we can approach this. I'll also have to think because we are thinking aside. So yeah, 1 is there. Now with 1, what we can do is we can introduce n and then 2 and n minus 1. If there is several version, there is no solution. So for 1, 2, 3, I guess there should be no solution. What about 1, 2, 3, 4? Again, no solution. So, and what about 1, 2, 3, 4, 5? For 1, 2, 3, 4, 5, what we can do is 1, 3, 2, 1, 4, 2, 5, 3. Something like this, maybe. Yeah, so it actually is possible. So it is very evident that if n is less than equal to 1, 4, our footprint is yes, footprint is no solution. No solution, right? Else, right? Else, what should we do? Um, else, what we should do is okay. So let's say we have 1, 2, 3, 4, 5. Okay. Now what we can do is we can divide 1, 2, 3 into one part, 4, 5, 4, 5 into another part, and then insert 4 here, 5 here, right? This is one of the solutions which we can say is fine because it's if let's say 1, 2, 3, 4, 5, 6, 7 is there. So what we do is we divide 1, 2, 3, 4. We put 5 here, 6 here, and 7 here, right? And that should work. That should work, right? So we are dividing it into two parts. And what about if it is 1, 2, 3, 4, 5, 6? We again divide it into two parts 1, 2, 3, 4, 5, 6, right? Now again we start putting values and boom. So basically the tricky one is if n equal to 5, let's just print the solution. I'll suggest 4, 2, 5, 4, 5, 3, 1. Else what we can do is it's not it's not also I say tricky again. But let's say we have an array and dot push back I, right? This is it, I guess. So now we divide this array into two parts. Okay, what we can do is we know what our n by 2 is, right? So in the case of 7, that equal to C1 and we'll make our ceiling function in text comma y. I don't know if I'm making it a bit complex or not, but I guess this should work. Mm, X is if x modulo y equal to 0, then we do return x by y. Else we return x by y plus 1, right? That is understandable. So now we have the midpoint, and after this mid value, like let's say for 7 we will have 4, and after this 1, 2, 3, 4, and 5, 6, 7, right? So from z plus 1 to n, we will have one part, and from 1 to z, we will have one part, and in between, every time we will input one thing. So let's say for int I equal to 1, I is then equal to n I plus plus. If I modulo, and we will start one counter from 1 and one counter from z plus 1, right? So and if I modulo 2 is equal to 1, see out what should be the value. It should be counter 1, else it should be counter 2, right? And we increase both of them simultaneously. And this should give us our value, I guess. I don't think they shouldn't have any problem. Um, let's see. For three more solution, what about eight? That's an added once. Again, that thing will come. So please excuse me for that. Yeah, exactly. This was what I was talking about. Please stop. 152637 2 ATM. I think it seems fine. Uh, why is this unresponsive? Let's submit this code and move on to the next question. Not a question on which we should invest a lot of time, but I took some time. I'm sorry for that. Oops, ouch, 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 ouch. Let's see. 1 equal to 1 equal to 4, there is a solution for 1 3. Okay. So if n equal to 1, see out 1, right, and 0. If n equal to 4, see out 2, 4, 1, 3, I guess. Yeah, it should have come to my mind. Yeah, let's submit this. String is almost done. Yeah. So I hope you liked it. If you liked the video, please subscribe and like and comment and share with the friends. Thank you.